In the video that introduced the concept of limits, you saw a simple example of how we can look at the graph of a function and determine the limit at a given point. And in this video, I want to take that a bit further and show you some more complex examples. And so we are going to find the limit as x approaches -3 of f of x, the limit as x approaches -2 of f of x, the limit as x approaches -1 of f of x, and the limit as x approaches 2 of f of x. All right, let's take a look at number 1. We want to determine the limit as x approaches -3 of f of x. And remember, the limit has to be the same from both sides. So what the function is approaching from the left side must equal what the function is approaching from the right side. So let's look at this one step at a time. All right, if we take the limit as x approaches -3 from the negative side, that's how we write it, of f of x. We're looking at this portion of the graph, or this portion of the number line, which corresponds to this portion of the graph. And what y value is it approaching? If you trace this over, you can see it somewhere between -0.9 and -0.8. So let's go ahead and say it's equal to -0.85. All right, now let's look at what's happening as the limit as x approaches -3 from the positive side. And that corresponds to this part of the number line and this part of the graph, right? So as we're approaching from the positive side, if we trace this over to see what the y value is, we can see it's approximately 0.7. These might not be perfect values, but we can see that approaching from the negative side and the positive side, we have two different values. So we would say that this limit does not exist. All right, let's look at the second example. In the second example, we're looking at the limit as x approaches -2. So again, we want to look at it from the negative side and the positive side. And in this case, as x approaches -2 from the negative side, that corresponds to this portion of the graph. And notice it's approaching a y value of 0, isn't it? And as we're approaching from the positive side, corresponds to this portion of the graph, and it's also approaching the y value of 0. So since those two values are the same, we can say that the limit as x approaches -2 of f of x is just 0. All right, I want you to take a moment, pause the video, and see if you can't figure out the fourth example, which is the limit as x approaches 2 of f of x. All right, we're going to skip over the third example temporarily, and I want you to go to the fourth example, pause the video, and see if you can't find the limit as x approaches 2 of f of x. All right, so if we look at that example, as we're approaching 2 from the negative side of f of x, that corresponds to this part of the graph, right? And so it looks like it's approaching a y value of -0.5. And if we're looking at the limit as x approaches 2 from the positive side, that corresponds to this portion of the graph. And it also is approaching a y value of -0.5. So your limit then would be -0.5. And hopefully that's what you got for your answer. Notice that at 2, so if we looked at f of 2, the value is actually -1. F of 2 is actually -1. But that does not affect the limit. Remember, the limit is what the function is approaching. We're not concerned about what's happening exactly at 2. All right, let's look at example number 3, which is our final example. And we want to determine the limit as x approaches -1 of f of x. And so if we look at what's happening as x approaches -1 from the negative side, we see that that corresponds to this portion of the graph, right here. And it's a little hard to tell from this picture, but this is actually a vertical asymptote right here at -1. So that means that the function will never cross that vertical asymptote. So actually what happens, if you recall from pre-calculus, is when you see a vertical asymptote, the graph will shoot off and it never cross that. So it's going off to infinity, isn't it? It's going off to positive infinity. And if we look at the limit as x approaches -1 from the positive side, that corresponds to this portion of the graph. And it too is going to positive infinity. And since those values are equal to one another, we can say that the limit as x approaches -1 of f of x is equal to positive infinity. So in that last example, I said the graph was a bit contrived because I wanted to show you a few different scenarios. So now I want to show you a couple of examples of actual functions and their graphs and how we can use those graphs to find the limit of the function at a given point. All right, so this first one is f of x is equal to x squared minus 4 over x minus 2. And I want to look at the limit as x approaches 2 of x squared minus 4 over x minus 2. All right, and if you were to graph this on your graphing calculator, or if you use the Desmos graphing tool, you might see this look like a solid line and you wouldn't see that hole. But if you were to zoom in enough and you were to try to trace the function with your tracing tool, and you were to look for the value, the y value at x equals 2, you would see that it's undefined at that point. Remember though, we don't need it to be defined at that point. We just want to find what it's approaching at that point. So if we look at this as x approaches 2 from the left side, that corresponds to this portion of the graph. And you can see that it's approaching 4. And from the right side, as we're approaching 2, that corresponds to this portion of the graph. And you could see that it's approaching 4 as well. So we can see that the limit as x approaches 2 of x squared minus 4 over x minus 2 is just 4. All right, let's look at the second problem. This is the graph of g of x equals the absolute value of x minus 2 over x minus 2. And this is the graph above it. And we are trying to find the limit of this function as x approaches 2. And I'm making these problems up, but this is the actual graph of g of x. All right. And I'm asking you to find the limit as x approaches 2 because I see a situation there that I'm trying to point out. All right, so if you were to approach 2 from the left, that corresponds to this portion of the graph, and you can see that the y value all along there is going to be -1, isn't it? And from the right side, as we approach 2, it corresponds to this portion of the graph, and that approaches a y value, actually all along there has a y value of +1. So from the left side, the limit is -1. From the right side, the limit is +1. Since those two values are not equal to one another, the limit does not exist here. All right, so for this last problem, I want you to look again at the limit as x approaches 2 of h of x equals 1 over x minus 2 squared. All right, and we're approaching 2 from the left side, and that corresponds to this portion of the graph. Notice what it's doing. It's shooting off to positive infinity. We can call that an infinite limit or unbounded limit. And as we're approaching 2 from the positive side, it's also shooting off to positive infinity. And so we can say that this limit is positive infinity.